Now let us talk about conical pendulum under circular motion. So what is a conical pendulum and how do you tend to work out some problems involving conical pendulum? So before I solve this question, I'm going to give you the basic idea behind conical pendulum. How can you find the speed? Okay. So now what I'm going to do is I'm going to use the same diagram which we have here. So under conical pendulum, what we need to understand is that something is revolving around the circle. An object is moving around the circle. But that thing, it is moving at an angle. So it is a pendulum but moving in a circular path. Okay. So if this is a conical pendulum, we definitely know, guys, that from this part here all the way to there, that is my radius. Okay. And that is my length. Now I can definitely see that if I want to find the radius in a case where I've not been given the radius, using SOHCAHTOA, if you have not been given the radius and you have been given the angle, that angle we have here is theta. Okay. So if you are trying to find the radius, because radius is very important, but length, they can give you the length, but sometimes we can't use it, but we can just use it to find the radius. So I can use sine theta. So sine theta is basically opposite is r, which is the radius, divided by the hypotenuse, which is l. Therefore r is l sine theta. So whenever I'm going to be doing, when I start driving the formulas, when I want to find my r, I need to use l sine theta. Okay. Now I'm going to put all the forces that are acting on this object. So what I'm going to do here is I'll just do it here like this. Okay. And here is our bulb. And we have been told that, and we know that when something is moving, so when something is moving and it is in air, it is under the influence of gravity. So gravity want to pull it down. That is my mg. And I definitely know that that is going to be my tension force. The force supported by the rope, it is tension force. Now this tension force, for us to support the weight force, is going to have the x component. Okay. It's going to have the y component and the x component, like that. So one thing we should take note is that the angle which I have here, what I have here is like this. Here there is 30. So the angle that I have here, it is making z. It's basically the same as the angle I'm going to have here. So here I also have 30 degrees. Okay. So this is my ty and this is my tx. When I do this, the next thing is I need to start working around with the forces. I want to find the formula for the velocity, how fast the bulb will be moving. Okay. So I'll start with the forces in y direction. I'll say this object, it is moving in the circular path, and we can clearly see that it's moving in x direction and not in y direction. Okay. So it is moving in x direction, so meaning that in y direction the net force is 0. So the summation of forces in y direction, we have got ty pointing upward minus mg pointing downward. Replace the net force with 0 because you see it's not moving in y direction. So t, according to SOHCAHTOA, this is the opposite, oh no, it's adjacent, sorry. Opposite is tx. So tx will be t sine theta, ty will be t cos theta. So this is going to give me t cos theta being minus mg. Now I'm going to shift this mg to the other side, which is the same as just saying t cos theta being equal to mg. So let's call this as equation 1. Okay. Now let us also try to see the forces that are acting on in x direction. So the summation of all the forces in x direction, in x direction we only have one force, and this force is pointing toward the positive x-axis, which is dx. But now the object is moving in x direction, therefore the net force is mass times acceleration. So it will be mass times the acceleration, which we're talking about here. Acceleration which is toward the center is the centripetal acceleration, being equal to tx. Now if I take you back, I know that centripetal acceleration is v squared, okay, divided by r. So then this will be replaced by m v squared divided by r, being equal to tx. We know that is t sine theta. Now we are going to call this as equation 2. Our goal is to find the formula for the velocity, but I don't have the tension force. How can I eliminate the tension force? So you have to check the equation 1 and equation 2. Which equation has got tan has got cos? The equation that has got cos, you have to make t as a subject of formula, so that that cos should be on the denominator when you plug in the values, and then it's going to give us tan. Okay, so the first equation, I'm going to make tension force as a subject of formula. So it's going to be, I'll divide both sides by tension force. Is going to give me t being equal to mg divided by cos theta. What I've done here is I've just divided both sides by cos theta. So in the second equation, where there is t, plug in mg cos theta. Okay, so I'll say m v squared divided by r being equal to, where there is t, you plug in mg divided by cos theta, okay, times sine theta. So I know that sine theta over cos theta is tan theta. Okay, so I can get rid of this to create space here. Okay, I need to leave this because I'll need it. Okay, I'll do this. Now what I'm going to do here is, it's going to give me now m v squared divided by r being equal to mg tan theta. So one thing we should take note is that if you have not been given the mass, you can just cancel out the mass because there is mass everywhere. Cross multiply and you end up having v squared being equal to r g tan theta. In a case where you are trying to find the theta and you have been given the radius and the velocity, you can make theta as a subject of formula, then find from here. So here now I can get the square root. Okay, so v will be equal to the square root of rg tan theta. So this is the formula we are going to use. Now you have to derive this formula. So this is the formula which we are going to use for us to find the velocity. So how fast the bulb is moving, we can use it using this formula. Now this is what we call the linear velocity. Linear velocity. But we can also find the angular velocity. We know that there are also these formulas which are very important for us to know them. Okay, the linear displacement being equal to the theta, okay, theta times r, v is equal to w times r, then linear acceleration is equal to angular acceleration times r. So now if I have v, I can find the w. I'll just divide. I have got v being equal to that, divide both sides by r, then that will be given by v over r. So this formula is very important. Okay, and also that formula is also very important. At the same time, also this formula is also important. We need to know it. Then this is what we call centripetal force. So centripetal force, where can I write it? is given by um, mv squared divided by r, that is centripetal force. So now, after finding everything here, if the question is asking you to find the tension force, you come here and plug in the theta, everything you have, and find the tension force. In fact, if you have the mass, you can find the tension force directly. Okay, you can find the tension force just by using that. So now, this what I've given you here, I've just left one thing, but let me write the important things on top here. So the formulas which we have just come up with, the ones which are very important for now, are to find the angular speed, to find the v is given by the square root of r tan theta. But you have to drive this formula because it's 10 marks. Then angular velocity is given by v over r, like that. We have found that. If I want to find the tension force, the radius we already have that side, so I'll get rid of this. But what if I want to find the centripetal force? So the centripetal force is given by mv squared divided by r. At the same time, I can also find the tension force using mg divided by cos theta, provided that I have the mass and the theta. What else are we supposed to get from here? Okay, we can find a lot of things, but another thing which I have to mention to you when I'm talking about conical pendulum is this. Apart from these, when an object is moving around the circle, then this formula is true. Velocity is equal to distance over time. The distance covered, or the distance is going to take for it to complete one cycle, we call it the circumference of the circle. The circumference of the circle is 2 pi r. I divide that by the t is the period. The time it takes to complete one cycle is the period. Okay? So I can use also this formula. Provided that I have the period, I can use this formula to find the velocity. But it is in rare cases. Now, I want you to understand one thing. We do know that v is given by this. Okay? V is, we say that v is given by wr. So I can replace w if in a case where I want to find the period and I've been given the angular speed. So I can replace v with wr. So it will be wr being equal to pi r divided by t. Now at this point I can cancel r. So if I cancel r, w will be equal to 2 pi divided by t. So this formula is also very important. I want you to know. Meaning that t in this case is a period. So I can also find the period. The time it takes to complete one cycle is what we call the period. I can find the period making period as a subject of formula here. Or before I go to the period, I can also know that if I isolate this formula and make it like this, 2 pi times 1 over period, okay, times 1 over period, and I know that period is equal to 1 over frequency, okay, meaning that frequency is 1 over period. So I can say another formula. If I have the frequency, I can use this formula to find my angular speed. Okay, that is another formula I wanted you to know. Now in a case where I want to find the frequency, you can make f as a subject of formula, where you're going to say the frequency is given by w divided by 2 pi. You can use this. Or the frequency is given by 1 over period. But I can also make period as a subject of formula here direct, and I'll see that period, if I cross multiply, it will be wt. Period will be equal to, okay, it will be like this. Period times w being equal to 2 pi, then divide both sides by w, so 2 pi divided by that. That's how I can find the period. from what I've explained here, guys, you can solve any type of question under conical pendulum. Any type of question. So from what I've explained here, we can clearly see that if I go back to this question, a small boy of mass m revolves in a horizontal circle at a constant speed at the end of the rope of length 1.2 meters. As the body revolves, the rope describe the surface of right circular cone as shown below. If the same angle of the of this is 30 degrees, calculate the speed of the mass in meters per second. So they want us to calculate this. Now, if I want, I can use this, provided that I have got the period, but I don't have the period. I can't use that. So the only formula I can use is this one because I have everything now there. So what I'm going to do is I'll get rid of this part. So let's see. So R, we have said R, it is L sine theta. Because I have not been given the R, but I have the length. So I can find R. So R is, the L is 1.2 sine 30, which is going to give me R being equal to 0.6. Okay? Because 1.2 divided by 2, okay, 0.6. It should be 0.6. Yeah, 0.6. So my radius is 0.6 times 9.8. Then we have tan. The angle is 30 degrees. So what is my V? So we have 0.6 times 9.8 is giving me 5.88. So what is 5.88 tan 30? I get 3.3948. I get the square root of this. That is 1.84. So 1.84 meters per second is my velocity. So as you can see, it will be very much easy for you now to solve this as long as you follow the steps, because I've explained almost everything which you are supposed to know under conical pendulum. The second question was saying, calculate the speed of the mass in rad per second. They want us to find W. Now I have the V, I have the radius. I can use this formula to find W. You see now? It's simple, right? So I'll just say W is equal to V is 1.84. The radius is 0.6. So W will be equal to, I'll say 1.84 divided by 0.6. That is 3.06, which is 3.07. 3.07 rad per second. As simple as that. Okay. Now the next question is again saying the time it takes to complete a revolution, or the time it takes to complete a revolution. The question was supposed just to be like the time it takes to complete one revolution, not the time it takes a revolution completing one revolution. The time it takes to complete one revolution is the period. Like I said, period is defined as the time it takes to complete one cycle. One cycle is one revolution. So they want us to find the period. Now we want to find the period, so you can use here, there are different methods which you can use. Okay? We want to find the period. If you want, you choose, but the answer is going to be the same. I gave you this formula. You can make T as a subset of formula, okay, of which is going to be the period. The period will be equal to 2 pi divided by V. If I use this formula, I also use this formula, I'll end up having the same answer. Why are we saying this? Because one thing we should know is that okay, we can use any, but we are going to end up having the same answer. Let's try to use both. We see if we're going to have the same answer. So the period is given by 2 pi times the radius is 0.6. I divide this by V, which is 1.84. So the period will be equal to, so we have 2 times pi times 0.6. I divide this by 1.84. So I'm getting 2 seconds, 2.04, but it's just 2.0 seconds. Now if I want, I can also use this other formula, but I should get the same answer. I can use this one for the W. T will be equal to 2 pi divided by W is 3.07. The period will be equal to, so we have 2 pi divided by 3.07. I'm also getting 2.04, which is just 2.0 seconds. So as you can see, you choose which one to go with and you end up having the same answer. So these are the basic idea which you are supposed to know under conical pendulum, and it is very very important for you to know this. What I've done here is I've explained almost everything, so now we can go back and explore different type of questions under conical pendulum and you'll be able to answer any type of question. Okay, so that is it for conical pendulum.